All right. Hello, everyone. So my name is Adrian. I'm a principal architect at Google in the Web3 team. I have around 8 years experience in crypto. I started doing smart contract analysis in a cybersecurity company. Then I worked as head of engineering for Consensus. So I worked on MetaMask and Infura. And yeah, now working at Google. Very nice to meet you. I'm going to be co-presenting with an expert of security.
Hi everyone, my name is Josh. I need to come in focus. Yes, my name is Josh. I cover cybersecurity in general for Google Cloud. I cover it for Southeast Asia as of today. Web3 is something that I recently got involved in. I do have some experience with crypto, but don't have the stars that Adrian currently carries. So that's me.
Very cool. All right. So we'll present kind of like how to secure Web3 applications. But first, I just have a quick slide that recaps a little bit what Google is doing in the Web3 space, because there is a lot happening. It's not just Google Cloud doing stuff. Google Cloud is at the forefront of leading really this crypto strategy, but we have a lot of more entities also touching crypto. Google Cloud has around 100 FTE working on Web3. That's why they are kind of like leading the crypto strategy. We have Web3 experts, we have Web3 experienced people, we accept crypto payments. There is a lot happening with our customers in Google Cloud. But we also have Google Labs, formerly Google X, that has a dedicated team for Web3 as well. They work on ZK, they work on ZK search integration. So maybe you've seen when you type your wallet address on Google, you can now have some balance IDs and stuff like that. This is the first step, and it will go a bit further. But the idea is to try to create some kind of standard around it. We also run a lot of validators on a lot of networks. Recently, we launched EigenLayer Operator, which is kind of cool. We run Ethereum nodes as well, of course, but Polygon running, there's a bunch of them. And it's really part of the ethos of bringing decentralization, making the networks more secure, and so on. So we also do some stuff on the Google Play. So maybe but we have new policies for NFTs. It's really a first step. You can't yet buy with crypto NFTs on applications on the Play Store. But maybe we'll get there. It's a good first step to enable NFT applications on the Play Store. So they're working as well on that front. And of course, we also invest in Web3 companies. Maybe you don't know, but we have actually invested in Fireblocks, and we have invested in Bored Apes, right, in Yuga Labs. So I personally like this one. Okay, so session will focus on security. And I thought it would be very interesting to look at the security trends and like based on the discussions that we had with our customers, what was the main trends. And if you focus on the first two ones, decentralized security, transparency and monitoring, I think those are the trends that are very inherent to Web3, right? It's like everything is transparent, everyone has the source code, everyone can make bots to liquidate people on DeFi protocols, everyone can see everything. So it's really the Web3 ethos, and that's what brings resilience and security to the space. I have the ImmuneFi, for example. I have some example on the right here. But how can you secure the space, being more resilient by giving access to everyone to do whatever they want and try to penetrate the systems, protocols, and so on. Regulatory adaptation, I think this is very keen, especially nowadays with what's happening with the SEC. But like when you look at what travel rules that happened recently, like KYC, KYT kind of like regulations, Web3 will have no choice than to adapt and have new tools and new security like capabilities to adapt to these regulations. AI, I think we have to talk about it. It's being incorporated everywhere in our tools as well, and I think Shash will talk about it. But it's really kind of interesting as well. You have some companies like Forta that are including that are using AI to detect anomalies within transactions and stuff like that. Advanced cryptography, this one also is kind of inherently to Web3. You have a lot of stuff around ZK, MPC, multisig, DVT, all of this advanced cryptography that makes the space more resilient, right? Because if you lose access to one validator, then thanks to DBT, you're not slashed, like you have more resilience on the validators. MPC is the same thing for your private key. You have more resilience around your private key. And ZKP with ZK rollups and so on. This is all very new, right? If you look at it, ZK rollups were not a reality 1 or 2 years ago. DBT is really starting like right now, right? So it's quite interesting. The research, of course, it has been existed for a long time. Security engineering, I won't talk too much about it, but user experience as well, very important. More and more you see wallets where you have, you can preview transactions and you can avoid mistakes that users can do, right? So a famous one was, there was an influencer, I think, who imported the ledger seed on MetaMask, which is kind of nonsense. And so this kind of stuff could be prevented, right? Like by improving the user experience. All right. So what's at stake? It's hard to estimate, right? Of course, but Chain Analysis has done some numbers here. We estimate around 12.8 billion stolen from 2016 to 2023, which is obviously way too much, right? And not very good. And most of it, if you look at the small diagram here, I don't know if you can read, most of it is due to on-chain hack and at the same time compromised private keys. But if we look really like at the top crypto heist, right, and what caused it, we can see a common point between all of them, right? And the common point is that they are all in the compromised private key category, right? So one way or another, hackers manage to either get direct access to the private keys, or they manage to get access to the APIs that manage to sign fraudulent transactions, which leads, of course, to the same thing, right? So all of them are the same kind of idea, compromised private keys, and they have, we then can split kind of like the categories of how it was done and what was hacked into 5 pillars that are wallet key, and key management, code and secret security, because maybe you don't control the wallet and keys directly, but you have code and secrets for access to an API like Fireblocks, for example, and you still need to secure those as the same as if it was your own private key. Infrastructure security, of course, because that's global. Device security, very important as well for phishing. Ledger recently had a hack as well that was linked to this. Application security. So if any of these pillars fall, it's not bad. It's bad, right? So we'll see how we can cover these 5 pillars. And the idea is that we look at a typical Web3 applications, and we will basically look at all the ways that we can secure it, and Shash will make us go through it. And when we look at the typical Web3 application architecture, it looks a little bit like this, right? I know some people don't have a key infrastructure, like Nansen, for example, because they don't need to access the data, but they will still manipulate blockchain data. So a Web3 company will at least either access blockchain data through a node infrastructure, or have key infrastructure to sign on behalf of users, or to sign their admin, functionalities on their smart contract. So at least the node infrastructure or the key infrastructure will be present in a Web3 application. Otherwise, it's not a Web3 application, right? But the typical Web3 app will have a front end with some kind of SDK, Connect wallet, like something like Rainbow Kit that would enable Web3 users with a wallet, whether it's MetaMask, whether it's Rabbit wallet, whether it's any kind of wallet, to connect to the front end. And then this front end will, of course, communicate with the back end with some kind of caching database or database to handle the business logic, which is not very relevant to what we want to show. What is relevant, however, is the listener, right? There will need to be some kind of microservice or mechanism to extract the data that they care about from the blockchain. And on top of the security aspects, there is a lot of efficiency aspects and how to best architecture it, but that can be another conversation. But basically, this listener is how to connect to the node infrastructure. And these nodes can be a service provider like Alchemy, Infura, QuickNode. So like an external service. It could be Nansen. It could be this kind of stuff if you do analytics. But most of the time, you would also need some kind of like real-time data. So you could use something like Alchemy Notify, Morally Stream API, or you could have your own node in your own infrastructure, right? Here it's outside, but it could be inside as well of your on premise with something like you run it in your own VM, or you run it in a Kubernetes cluster, or we even have a tool, blockchain node engine, that can have dedicated nodes for you that are fully managed, but inside your infrastructure. So you have multiple options, but the idea is the same. How do you secure this connection with the node, whether you own it or not? For privacy reasons, but also for security reasons. And then, of course, the most important for the applications that have it is the key infrastructure. How do you secure that? Key infrastructure can be built internally, like inside the premise. So that's what is shown here. Using some kind of like KMS or HSM, even some sophisticated databases like HashiCorp Vault. These can be built inside your premise, but it can also, and a lot of people use service providers like Fireblocks, a custodian, Credo, BitGo, whatever it is. And this custodian, these service providers is not the perfect solution as well, right? Because now the access on how you access these providers, the API keys, the policies needs to be very secure as well. And Shash will go through the different stuff that we can secure in this application, and hopefully you have questions and you learn a lot.
It's not over. It's not over. Hold your horses. All right. So very quickly, what we'll do is we'll sort of do a quick threat modeling of this architecture itself, right? So the idea is, he already explained, this is an abstracted architecture. It's not a full deep down architecture, primarily because we're not really interested in how you build the front end, how you build the back end. We want to understand, if you were to target this, what would you go after, and what are the Web3 components that we need to secure, right? So we look at this from an attacker's perspective, outside in. So, and one of the things that we will focus on, actually the only thing that we will focus on would be the components that are highlighted in red. Why? Because in this case, we're taking the perspective of an app owner. Imagine yourself as a Web3 app owner, and you are working with us. So how can we help you? Basically, that's the perspective, right? We could also show how we would secure the transaction, in this case, between the MetaMask wallet as well as the Connect service that we have. But that would be from the perspective of Meta Wallet or MetaMask being our customer, right? So if they were our customer as well, then we would basically secure the entire chain, the end-to-end workflow. So in this case, we'll just take the perspective of Web3 app. So how does this work? We'll first look at the front-end piece itself. Very simple. None of this is Web3. This is actually all Web2. Going back to Web2. So the first piece would be to take care of certificates, CLS certificates, so load balancers that are potentially used to sort of balance between whatever infrastructure you have that is serving the front end. It's quite simple. Google provides a load balancer that is distributed, that is globally distributed, and we have a small certificate manager as a service that is deployed inside of it. You can deploy Google managed certificates, or you deploy your own managed certificates. It's not super complicated. It's quite simple. That's the first piece. The second piece of this would be, how do you handle application layer attacks that are coming in, again, from a Web2 perspective? So that's where we put in our WAF product on top of it. So the WAF product is also sort of deployed within the load balancer infrastructure itself. That front-end infrastructure, we call it GFE. It's called Google Front-End. It's fully managed by Google, and we take care of scaling it. We take care of securing it. We take care of all of the traffic that hits it, basically. And it comes with an AI engine that is built into it. So organizations, if they don't have their own security team, and they want to understand what kind of attacks are being targeted into their applications, they can rely on the AI engine. It'll spit out rules based on its understanding of the attack traffic on your application, right? And most recently, we launched another capability into it where you can actually give full control to the AI. It will actually identify, understand, detect, come up with rules, and also deploy those rules to protect the application. So it's going to be fully self-reliant by itself. You can even call it sentient if you'd like. So that's kind of how it works. And we are famous for blocking one of the largest DDoS attack that happened most recently. The attack traffic had about 46 million requests per second. So that's the scale at which we are able to sort of protect Web3 applications, or any application for that matter, that is served over HTTPS. The third layer to this, again, application security, is using something to protect bot-based traffic. One of the most recent stats is that about 70% of traffic that hit Web2 applications, and we're not talking Web3, Web2 applications is bot-based, primarily because if there's any transaction happening on those applications, it's mostly coming from bots. If there's any resource that is valued by people, for instance, let's say Nike comes out with a new pair of sneakers that are highly debated, highly contested, bots are potentially buying those instead of human beings, because then they would sell it later in secondhand markets, right? So similarly, the same thing happens for Web3 applications, so over Web2, that might have potentially resources that are of value. That's when bots basically attack this specific application. So reCAPTCHA is our solution to sort of deal with this. What it does is it potentially identifies malicious traffic. So what we do is, in the past, we used to actually have a simple reCAPTCHA challenge. This is what most people know. It's a text-based challenge. Then we moved on to an image-based challenge. And again, most people think of this. But now we have nothing. It's invisible. So when I say nothing, it's basically you don't see anything. The CAPTCHA challenge is invisible. The CAPTCHA challenge is actually for the computer that is potentially accessing the application. So if you have, let's say, scripted something on your own terminals or your own browsers, Selenium is one framework that you could potentially use for that. And if those scripts are potentially accessing the application, then we will be in a position to detect it. Let's say you're mimicking yourself to be coming from iPhone. So we can actually detect if it's a real iPhone, because iPhone has other things that's going on inside of it, such as a gyroscope. So we'll be able to sort of figure out if there is a gyroscope in the device, even though it's advertising itself to be an iPhone. So these kinds of things or characteristics, device characteristics, we are able to identify based on a small script that we launch as if you enable reCAPTCHA, invisible reCAPTCHA with us. So that allows us to constantly study the traffic, constantly study the source of the traffic, as well as the behavior of that traffic on your applications. And we can potentially flag out what is a bot or not. And the way we do that is by providing a score. And it's provided on a spectrum between 0 to 1. So higher the value, if it's like 0.5 and above, that means it's highly likely that it's a bot. If it's lower, that means it's highly likely that it's a human being. And the way developers use this is they will integrate that into the application flow. So let's say in this case, the score is less than 0.7. That means it's highly likely that it could be a human user. So you want to route them to the real application itself. But if it's something else that you consider to be bad, let's say it's above 0.7, then you can route them to something like a honeypot infrastructure, where you want to study exactly what these people are doing when they use bots to access your applications. So that's reCAPTCHA in a nutshell. But reCAPTCHA is now sort of grown into a fully baked fraud prevention solution. I won't get into all of them. Some of them are sort of relevant. For instance, account defender, payment defender, even like API-based protections. You have something to talk about that, right? So Adrian has a couple of use cases where we use this for Web3 companies. So I'll
I think reCAPTCHA is especially important for Web3 companies because it's directly linked to money, right? Of course. And so you have a lot, as we've seen, like the chain analysis pie chart, we're saying that a lot of it is price manipulation and a lot of it is on-chain hacks and stuff like that. These kind of things also are created through bots, and it goes through, creating some kind of Sybil attacks where you think that you have multiple users, but it's actually one. And so this has a direct consequence for airdrop farming, for example. A lot of airdrop are struggling with Sybil attacks because you don't want to airdrop the same person that has created 1,000 wallets. And reCAPTCHA is directly using and mitigating this kind of stuff, but you have a lot of other stuff like protocol consensus, right? You don't want Sybil attacks on protocol consensus that could have more dramatic effects, and then also DAO voting and stuff like that. So this kind of stuff are really problematic, and so it's helping a lot of Web3 companies basically.
So it helps detect fraud, it helps to detect application attacks, reflection attacks. These are all like Web2-based attacks, but it still impacts Web3 applications, because most Web3 applications are still working off of Web2, right? So I'm going to keep switching between Web 2 and Web 3, so don't mind me, but we're going to keep it real. All right, so the next piece now is we've taken care of the front end. Let's look at what happens when you enter the GCP infrastructure. So how do we sort of secure this? So the first piece is quite simple. We use a firewall that is integrated into the VPC itself. How many of you know what a VPC is? Yay, fantastic. Okay, so basically the firewall is integrated into the VPC itself. That allows you to define rules that could be hierarchical in nature. So you can define rules that are hierarchical, starting all the way from the organization, that gets inherited by things that are resources that are under that organization, right? And what we've also done most recently is we've integrated this with an IPS engine that comes from another security provider called Palo Alto. Some of you might know them. So we've integrated their sandboxing engine into this. So what we are now able to do is we can extend this firewall capability from a basic firewall to something that also inspects payloads. So let's say there is a piece of payload that gets through the WAF, gets through the load balancer, gets through the firewall, and eventually lands in front of the application before the application starts to process it or passes it on to the backend. The IPS engine can actually scan, can actually analyze the payload that is being uploaded, and it can block it, if at all, if it's considered to be malicious, right? So that's another additional capability we recently introduced. The next piece, and notice that the color changes for the two backend infrastructures, the backend and the key infrastructure. The reason why we did that is you also want to secure that communication between those two components. You could use a key infrastructure that is provided by Google, so we have our own KMS. You could also use a third-party key infrastructure that is provided by the, organizations like HashiCorp, for instance, or you also have Fireblocks, right? Adrian's going to talk about that in a short while. But whatever it is that you're using, whether it is sitting inside the blue components, which is the GCP environment, or whether it's sitting outside, you still want to secure the communication between them. So the way to do that is to use something called as VPC service controls. So the idea here is you define perimeters between the two components that you want to communicate with each other. That means anybody outside of it, if they try to communicate with them, they'll be blocked or they'll just be denied by default. And you cannot compromise these systems because you cannot enter those systems in the first place. So it's sort of like positive security model, but implemented between two components. And the typical way the VPC service control works is to not just protect communications between services that are outside GCP, but also to protect between two GCP services themselves that are communicating with each other. So it could be like a virtual machine or like a container that you've created and it's trying to communicate with some other GCP service. You can actually define whether it is allowed to communicate or not. Because by default, any cloud provider, the infrastructure they provide, their internal services can actually talk to each other without any restrictions. So we want to prevent that also from happening, right? So we want to make sure that every communication is authorized and authenticated and and you have a paper trail on it. So that's what VPC service controls can define in terms of rules for, and typically it was originally introduced for data exfiltration as a use case, but in the Web3 use case, this is very important because we want to protect the private keys. Earlier, Adrian mentioned that some of the top use cases for attacks that happened recently, 12-point-something billion, right? Most of them are like all private keys oriented attacks. So you want to protect that infrastructure. I think Adrian has a couple of points on this, so I'll pass it on to him very quickly as well.
Oh yeah, just wanted to mention, right, specifically on the key infrastructure, it's most Web3 companies will use this tier approach that you have here, especially centralized exchange, because they manage wallets on behalf of other users. But they would use this tiered wallet architecture with hot wallets that are, of course, the most frequent where you need the most frequent transactions. So they would not be as secure as the rest of the wallets, but they would be sweep. You would have rotations every now and then, so that you never keep a lot of money on them. But they can be automated and directly stored on some kind of VMs or or less specialized kind of like databases. Then you would have the warm wallets that are adding a little bit of security on top of it for more critical operations, maybe with some kind of like MPC or even with some kind of multi-sig. And then you would have the cold wallets, of course, with Ledger and stuff like that, that would be completely offline. But you still need to integrate those signatures with your system, right? And so how to do that can be done using, again, right, some providers like Fireblocks. You can even have some decentralized solutions like Gnosis Safe, for example, where you can have multi-signatures kind of stuff using a kind of abstraction and stuff like that. But it's interesting to see that whether you can build it yourself using Google Cloud tools. You can use HSM, Google Cloud. You have confidential VMs. You have KMS and stuff like that. You can also use some marketplace solutions that we have. So Fireblocks is one, HashiCorp Vault is one as well that is heavily used in the Web3 space. But I want to highlight that if you use a provider, again, and I told it very quickly, but if you use a provider like Fireblocks, then the critical path for your security now becomes the API keys for Fireblocks, right? Because if someone managed to introduce your system, have access to these keys and impersonate your users, then they can steal your crypto the same, right? Because they can connect to Fireblocks and steal your money from there. So you need to secure these API keys the same that you would secure your private keys, but you also need to configure Fireblocks and these tools with policies, right? And be like, okay, if you need transfer of more than $1 million, then you would need 3 or 4 people. Maybe you would need a ledger coming in and stuff like that. So those are very important, but we can help, of course, build this kind of stuff.
Yeah, cool. Thanks, Adrian. We'll keep moving. Well, next components. So earlier, Adrian mentioned that there are a couple of options, especially for the listener interface. It needs to somehow get real-time information from a chain that it's connected to. And so you could have external services where the node is hosted externally, or you could also host the node internally. There's a couple of options here. So if you host it internally, then again, you have a few options. We also provide our own node engine called BNE, Google Blockchain Node Engine. Or you could also host your own through a virtual machine or a container or like Cloud Run or whatever it is. But depending on the choice you make, the security model will change slightly. So we're going to take the example of an external node just to illustrate a couple of additional points. So if it's an externally hosted node, you want to secure the communication that's going out now, right? So any outgoing traffic. So first of all, to create outgoing traffic, to make sure that it's going securely, you need to use a NAT. So we provide a component called Cloud NAT. That's just a simple networking interface that we provide. But behind that, we can provide a secure web proxy. So the secure web proxy ensures that the endpoints that you're reaching out to externally, those are validated first. So those are first whitelisted by your organization. Second, those are not malicious themselves. So it can actually also see if those are compromised by scanning them. And if there's an issue over there, it'll actually block outgoing traffic, right? So that's one way of sort of protecting that external traffic. The last piece to this is logging infrastructure and monitoring. Now that you've sort of potentially secured the entire chain, not necessarily the chain, but at least the infrastructure that's hosting all of this, you want to make sure that it's working as intended. So how do you make sure that it's working as intended? The first thing is you start logging everything, and then you start monitoring those logs. So you want to bring all those logs centrally, and you want to sort of run certain rules against those logs to see if you're able to detect any malicious activity, any anomalies, anything that you haven't potentially signed up for, right? So that's where we bring in a component called Security Command Center. This is our posture management / logging, monitoring, security solution that works through 5 pillars. We're also able to define compliance mechanisms in case you need them, so you can customize that also on top of this. But basically the idea is, once you've put all of the security recommendations that we provided earlier in place, you can monitor those security recommendations, and you can also enhance them by putting a logging infrastructure on top of it. Now that we've sort of taken care of the external and the internal security pieces, there is another user persona that we need to think of, and that is your own internal users. your admin users. How do you secure the access for these admin users? I think there was a famous case with Ledger, was it, right? Where the developer himself working for Ledger was compromised, and that led to other kinds of problems. We'll talk about this. I don't want to sort of reveal the whole issue already, but so you want to still secure that user. Why? Because, and Mandan will probably also talk about this later. If I want to target an organization as an attacker, I'm not going to target the organization. I'm going to target somebody who works for the organization. It's always that, because that's easy. Human beings are susceptible. You just have to get them on somebody's computer. It's over, and from there you can sort of get in, right? So that's why you want to secure that admin user. So what we have to secure the admin user is a solution called as Beyond Corp Enterprise. We've renamed it, but we'll keep the same name for now for simplicity. And the way this works is our recommendation is that you work through the browser, which is Chrome browser that we provide. We provide an enterprise version of it, which has sandboxing capabilities that are built into it already. So they can prevent bad behaviors of users on the browser through policies that are defined for the organization. So as long as your admins are accessing everything through the Chrome browser, we can secure the entire chain from the Chrome browser to when they land into the Google proxy and beyond that. So that's how it works. There's a lot more to it, but I'll just give you a high-level overview. So if you want to learn more about it, we can also talk about that. The second piece to this is to secure the CI/CD pipeline, the software lifecycle in itself. Everybody's heard of SolarWinds. Anybody heard of SolarWinds or not heard of SolarWinds? Yeah, I see some laughs. So okay, cool. You've heard of it, right? So software supply chain compromise is a big problem. Ledger also had the same problem, actually. So you also want to secure that piece. And the way to do that is to have some sort of a system or a package that monitors the entire development lifecycle, from building to testing to deployment, all the way to like pushing it to production, right? So all of those things, the entire chain. And you want to make sure that there are checks and balances at every stage. And there are policies in place, there's rules in place, and there's also detection capabilities in place to detect malicious code, policies in place to ensure that the right people have actually approved the changes that are going in, and all of these things, right? So that entire chain can be secured through a package that we've recently launched called Software Delivery Shield, SDS. So that's another piece that goes into this. Adrian, do you want to sort of add something to this?
Just wanted to share a little bit more about the Ledger case, right? Where one employee of Ledger was actually compromised. And this employee had access to the npm.js official GitHub. And he was able to, the hacker compromised this employee and was able to push a malicious version on the official npm.js GitHub, right? And so what happened is that every company that are using the Ledger kit, which is most Web3 companies, would, if they updated to the new package, then they would have the malicious code in the front end. And then every transaction that the users want to sign on the dApp would return a malicious transaction that are actually draining the money from the users. And this led to approximately 600 K USD of money stolen. And it could have been, prevented if they had in place this CI/CD tools and checks to make sure that, okay, who is pushing it, what time, and this kind of stuff. So, yeah, I think it was, a good example of what bad things can happen very quickly. There was also other issues with this case, but that's the gist of it.
Yeah, I mean, this is not a very uniquely Web3 problem. It's again a Web2 problem. It's a human problem. We've actually got a lot more examples of supply chain compromise and organizations, downstream organizations, getting impacted because of this. In the case of Ledger themselves got impacted. But there's also cases where like downstream applications can get impacted. So if a company whose code was compromised and that code is being used by somebody else, then they are compromised as well in some sense, right? So those are the kind of things that you want to prevent. And what we think that you can sort of prevent it if you used a packaging solution such as this to secure the CI/CD pipeline. Now, so far we've discussed infrastructure that is all on GCP. What if, it's not a question of what if actually, everybody actually has infrastructure also sitting somewhere else. So what about that infrastructure? So the infrastructure that sits in maybe your own physical servers or something that sits in some other cloud environment. How do you sort of monitor this, right? So for this, we have another hybrid solution. It's a monitoring solution again. It's called Chronicle Security Operations. Again, we're going to change the name, so I'm not going to, let's not harp on the name, but just grasp the concept. The concept is whatever you're running in that infrastructure and whatever you're running inside GCP infrastructure, you want a centralized place where you can bring everything together and you can sort of monitor what's happening across your overall environments. So that's where we are able to orchestrate this using something called as Chronicle Security Operations or Google Security Operations. So this will look for events across both infrastructure. Within those events, it'll look for incidents and things that could be malicious, and then it'll flag it out. And because it is centralized, it also has an orchestration capability for response. So the idea here is that there could be certain workflows that you're quite familiar with, where you know that, okay, this is a known issue, and here's a way to solve that issue. So instead of involving human beings to solve that problem, you can automate that response. So that response automation capability is also built into it. Thereby, in case there are issues that are already known to your organization or that are already documented by, let's say, security researchers in the world, then you can just automate those workflows very quickly. And if there's something that is uniquely discovered in your environment, again, you can also write automation to that for that use case within the environment to deploy it very quickly. So the idea is you want something that is always looking at everything that is happening inside your environment, and you also want to respond to it quickly without always involving human beings. So that's where this comes into the picture. Do you want to add some points on Web3 customers?
Yeah, I think it's important, especially for Web3, but big Web3 customers, and a lot of top crypto exchanges are using these kind of tools, and also big Web3 customers. The reason is decentralization means that you have to try and run nodes or your infrastructure on different cloud, different premises, and so the nature of it makes that usually you have multi-cloud infrastructure for Web3 customers, and maybe to try and make it on Google Cloud. So you have guides on how to do it on Google Cloud, how to do it on AWS, how to do it on Azure and stuff like that. And so it's very important to have this hybrid, right, capability to ingest the logs from all of these different places. Another reason is that it ingests a lot of data and it makes it very fast to query, right? But like petabytes of data we're talking less than a second to do any kind of querying on top of it, which is very important, especially on blockchain data. You have tons of data. It's a crypto exchange because of all the trades they're making and all the compliance they have to follow, but also any kind of Web3 company, when they ingest some kind of transactions, then they would end up with a lot of data from a lot of different chains potentially. So it's very important. And then all of these tools that makes it easy, like AI, anomaly detection, and also you can create your own rules and you can use natural language querying and stuff like that, makes it that as one of the top tools today used by Web3 customers.
Cool. Thanks, Adrian. And the last piece to this is incident response. Earlier, Adrian presented a slide with 5 components, 5 technical components. And at the bottom of that, he had a pillar which said incident response and recover. So why is this important, right? You had a slide, but okay, never mind. So why is incident response important? How many of you are aware of a North Korean group called Lazarus? You can't lift your hand. Lovely. So, and for those who lifted your hands, you know what they do, right? They target organizations specifically for cryptocurrencies. And it's estimated that in the last 4 or 5 years, they've stolen close to $2 billion worth of cryptocurrencies. North Korean group. Yes, this is a North Korean group. It almost sort of funds most of their activities, the government activities. They are a nation-state-backed or threat actor group that goes after organizations. Just most recently, I think one of the companies, they stole about $100 million worth of cryptocurrencies just by hacking their bridge network. So when such a thing happens to an organization, I'm not saying it will happen, but it might happen. It's a question of might, or a question of if, not if, but when, right? So when it does happen, how are you going to respond to it? And let's say instead of them trying to steal something from your infrastructure, they deployed a piece of ransomware and they held most of your important assets in ransom and demanded cryptocurrencies. How are you going to deal with them? How are you going to negotiate this conversation with them? These are important issues, especially for Web3 companies, because Web3 companies are targeted specifically by these kinds of nation-state threat actors. Most recently, we were working with another customer who, when we tried to talk to them about incident response, their response to us was, we're fighting these North Koreans every day. So they're like, we're battle tested. Our team is fighting North Koreans every day. We're like, well, I mean, we have no answer to that, right? Like, that's the reality. So to deal with these kinds of problems, you need an expert team that is already sort of battle tested against these kinds of threat actors, that already knows how to deal with them, that understands their modus operandi, and that has profiled them, and that can deal with them in case something happens to you. So that's the value of the mandated incident response, having it on retainer. So in case something goes wrong, they can reach out, you can reach out to them, and they can be your security people that can help you in this case. So that's where you put in the incident response to ensure that it has this oversight on all of your infrastructure and your business, and helps you sort of deal with incidents and recover from incidents in case something goes wrong. Arjuna, do you want to add something on top of this for the customers on Web3? Okay. So the final piece is, I spoke about a lot of solutions. So how do you sort of visualize them, right? So we took NIST cybersecurity framework as one of the ideas to sort of organize them. NIST cybersecurity framework is an industry standard that sort of organizes how an organization can look at their security posture. So there's 5 pillars to this: identify, protect, detect, respond, and recover. So everything that we spoke about so far, they're all organized under these pillars. So we will share this with you. So if at all you want to understand how do you sort of identify attacks happening, or how do you respond to these attacks happening, then you can use this framework to sort of inform yourself and respond. That's all we've got. I'll pass it on to Arjun for any closing thoughts.
That's it. No closing
That's all she wrote.
Hopefully it was helpful. Thank you.
Yeah.
For the time.